There were a couple other requirements in this one that are new. One is that any code using Magrittr should have one verb per line. The reason for that is that Magrittr and tidyverse in general are, again, designed for code readability. And what piping can do is actually replace nested functions the way that we did it in base R. So if you had, in base R, for example, you might put a function inside another function, as a parameter inside another function, inside another function, inside another function. That is the same as doing a chain of 4 pipes or 3 pipes. So you should always use pipes instead. And the one per line is for readability. So you're also not required to use all lines specified, which is an important piece. You might have used less lines in a couple of cases. If you found you needed more, then you probably were not doing it quite efficiently enough. So hopefully that made sense. There's also an expectation that you format it in ideal Magrittr format, which I covered in last time, which is that you have again you have one verb per line, but on that first line you have the source of the data and the assignment only. So either an initial assignment command or just whatever the data starts with. And that could be a command, but it doesn't necessarily need to be. Okay? We'll see examples of it in a minute. And hopefully you did it that way. Continue working on the same project in week 4. I hope that you recognized as you went that the first major data analytic thing you did in one line was essentially the entire last project. So at least the entire data cleaning part of the last project. So you can see how differently that looked in a tidy Magrittr format. A few extra pieces of information here. Each participant, again, completed the study 4 times with different versions of the stimulus. Not giving any details about what that stimulus is on purpose. The software used to collect it differed by lab, so you have different file formats. There are 9 focal study variables. That's the last time before. However, there are experimenter notes, and the presence of a note indicates there was a problem. So that's an important translation bit here, because you'll need to know that later. And then it gives you 9 focal variables with the additional piece here, same as last week's, except that one of the data files has a Q6 through Q10. And this is super important. Participant and case numbers begin at 1 for each file. That's very important because that means that participant 1 in file 1 is not the same as participant 1 in file 2. And that's a very common situation you encounter when combining data sets. So to start, I've already gone ahead and done the first bits of this. You can see now that our RStudio command is being collapsed down to a single directive. But it's still the same. Writing a comment, calling the RStudio library, and setting the working directory to where the file is saved. And I've also already gone ahead, I usually demonstrate this, but we're going to skip that step here and in the future. I've already saved the 4 data files that we have. So that takes us all the way to line 5, which is data import, and line 6 through 10. Using 4 tidy import functions, convert the 4 data files into A data tibble, A notes tibble, B data tibble, B notes tibble with appropriate column names. So there's the first hard part. What's the very first thing you should do upon seeing that directive? View the data files. So if we go back to here, we look at anotes.csv. Does that look like a stereotypical CSV? Yeah, pretty normal. We have commas. There's no quotes being delimiting, but that's okay. You have commas indicating there's a missing hole here, or missing value for those, and you can just scroll through and see all these if you want to look at actual data. So anotes.csv looks great. Participants.dat looks an awful lot like the last one, last project. We have the dashes, we have the date, we have the 5 contained within one variable. So that looks basically like what we had to deal with for the last project. bnotes.text looks similar to the other notes file, but with one key difference, which is what? No commas. This is delimited by tabs. So we have a tab delimited file. Another thing of interest here is the header. In participants.dat, we had no header, but in anotes and bnotes, we have headers. And then in bparticipants.dat, what format is this? This will operate as, you could interpret it actually a couple different ways. You could feed this as a tab-separated values file, even though there's spaces. You could alternatively use spaces as delimiters. Either way would work, because TSV will automatically do that conversion for you. So, so having that information enables us to craft a couple of commands, or a series of 4 commands, rather, to import them. So if I go back to week 4, I will, let's start with the notes files because they're a little easier. What did you use for a notes tibble? Read underscore CSV. We're going to grab it from data a notes.csv. Oh, I forgot a library command. It's okay. For b notes tibble, what do we do? That's the easy way. You know, it's that dat, or no text. A data tibble. What are we going to do? Read underscore delim. I'm going to go data a participants.dat. And this is going to look just essentially like last time. Our delimiter is a dash. And we're going to pre-specify our column names as a way to get all that stuff in there. So C, case num, parnum, stem, ver, data, date, and we use QS again, just like last time. Misspelled. A participants. There we go. And then B data underscore tibble. What are we going to do for that? With read underscore delim for this one? Yeah. Read underscore delim data B participants. And we may need to actually look at that data a little more closely if this doesn't work. I should see that. We ended up with what? Oh yeah, that's nice and weird. So let's actually try opening this file in text editor just to see what it really looks like. Oh, actually it's clearer here than it was there. These actually are tabs. There we go. Perhaps a reason not to use RStudio to preview your files. Yeah, so then space delimited actually wouldn't work. We could do that though. It'd be the same thing. And I'm going to do call names again here. Equals C, case num, parnum, stem ver, data, date, and we're going to use a paste 0 for Q and values 1 through 10. I got a comma. Thank you. You still get an error though, won't we? Oh, maybe not. Yeah, it looks good. Thank you. Data, what's it called? B data? Spelling is not good today. All right. Yeah, that works fine. Great. There we go. Okay. Data import done. So everything basically that we covered last time in terms of data import, now you will note, again, one thing you have to do in this file. So basically all the stuff that comes after this, same thing will happen in future projects. And again, good, follow developmental processes. Don't just run everything and assume it worked. We move into next requirement, line 12, data cleaning. Line 13 through 17. Using a single series of pipes, split QS into the 5 variables, convert them all to numeric, and convert data date to its correct type. Extra credit for scalability. So if we don't make it scalable, let's try that first. How would you construct this pipe series? Yes. So assignment operations always occur in the first. And in this case, if we're trying to update it, we save it back to itself. I will also give you a piece of information. If you import Magritter, you can actually replace that format with that. Is the same thing. But you'd have to use library Magritter. That particular pipe is not by default in tidyverse. So, first line, we have a data table gets a data dot tip underscore tibble dot. And then we are going to feed that into our next command. Our first command was Split QS into 5 correct variable names. How do we do that? Separate. And what do we feed to separate? QS into gets paste.
And then in parentheses, Q, comma, 1, 5, comma, separator equals empty quotes. And then end the parentheses, comma, separator equals quotes, space, and then pipe at the end.
Okay. So, in testing, and I hope this is what you were doing, you can run each piece of this before you add the next pipe and to check to see if it worked. So if we run right now a data tibble, that did work, and then we can glimpse a data tibble and see, yes, now we have a Q1 through Q5 with the correct pieces in there. We then need to go back up to a data tibble, Control-Enter to rerun the import, and now we're right back where we were again. So again, development, not writing. So test each piece once at a time. Can we simplify this a little bit? So we can use paste 0 because what the difference between paste and paste 0 is this is the default. So we can make it that. Can we simplify further? What's that? Yeah. Into and sep are the second and third parameters. So that means we can just do it like that. And again, we test. Looks like it worked. We glimpse just to make sure. Looks great. So then we go back, re-import, and now we're ready to keep writing. Yeah. Oh, if you did separate a data underscore table, comma, QS, comma, etc. Is that what you mean? Oh, you mean you literally put it like that? Oh, that's technically one verb per line, but you shouldn't do that. So that'll be fine for this, but I would not recommend doing that in the future. See, what you could have done, what I thought you said first, is this, which actually would be fine. Bloop, bloop, bloop. That would also work as a first line. Yeah, because then we're creating one data source from one verb. Yeah. So technically, yeah, it's not actually a verb, which is why I'm not going to count off for it. But technically, you're actually doing an assignment operation, which is like a verb. So just don't do that in the future. This would work though. We're gonna not do that right now. Nah, we're gonna do that right now. Let's make sure. That looks like it worked. And glimpse, yes, great. Re-import. Re-add pipe, ready for next line. All right, so next thing, convert them all to numeric. How do we do that? And again, the non-streamlined way first. Or did everybody do the streamlined way? How many did why can't I get the word right now? Scalable, thank you. How many people did the scalable version? Okay. Yeah, this is a harder scalable problem than previously. So what did everybody else do? What goes here? Mutate. Yep. So this process continued out would do what we needed to do. And I'm only going to type it out so that we don't waste a huge amount of time for the first two. And run it just to make sure. If we go back to glimpse, as we always should, you can see that it's converted these to doubles, which is the numeric format. So that would work. However, not at all scalable and really messy from a programming standpoint. If you want to avoid that, you would have to use a function that I did not tell you about explicitly, although I mentioned it. You would actually have to look into what function that, or what verb that is. What verb did you use? So for the folks that made it scalable, what did you do? Mutate at also? No? What'd you do?
In the separate command, after case, I put convert equals capital T.
Oh, you did it implicit in the separate statement? Oh, that's clever, because I didn't talk about that. There's another parameter that you can use in separate that automatically down converts to, it's like the S in sapply versus lapply. It automatically down converts it to whatever format is simplest. So if you add in right here, right, convert equals true, then it will automatically do that for you. So that is a scalable solution, so that's good. But that is not the one I wanted to demonstrate. So mutate add is the one that I wanted to demonstrate. So in order to figure this out, if you looked at the documentation for mutate, you probably would have found these guys, scoped variants. What scoped variance means is that you can, as it says, make it easy to apply a transformation to a selection of variables. So if you looked at the mutate documentation, you would have found that. Mutate if, you could have used. Mutate at, however, is a little bit easier in this particular context. If we look at the documentation for mutate at, you will see that the format is table, variables, function. So if we look down to how to do that, the tibble by default, of course, is piped in, so we don't need a tibble, which means we have to worry about variables and function. Well, that looks an awful lot like what we do when we do applies. That means we take some selection of something and then we apply a function to it. So that makes this part easy. So if I do mutate at, we're going to go ahead and do as.numeric. And the question becomes then, what goes here? What does vars mean? In order to figure that out, you could just scroll down to look for what are vars. And vars are a list of columns generated by vars, or a character vector of column names. So you could have done this either as C parentheses and then done a paste command to create a vector of words, or you can use the vars command. And if I go to vars, what vars does is it says it's a helper verb providing semantics to select. If we look at the arguments, it just says variables to include. Easy enough. So in our standard dplyr syntax, that means we can do vars q1 through q5. Done. Is that how you did it? Starts with q. That would work too. Helper verbs are super important in the context of dplyr. They help you do a lot of things. So vars is one example here, and if we run that, again, we want to go ahead and check glimpse to make sure it worked. And there we have, all 5 are now doubles, numeric format. So I'm going to re-import as we keep doing this, and pipe in the next. So either of those approaches, those are both scalable solutions. Mutate at, mutate if, those scoped variants also exist for the other stuff, summarize at, summarize if, etc. So you can use those in a lot of different contexts, and we actually will also use those a little later for another problem. So that's line 14. Also convert data date to correct type. How do we do that? You call what? Yep. Good call. And what else? If you did the other version, then it is a little bit easier to figure out how this works, because you would have just had q1 equals as numeric, q2 equals as numeric, etc., comma, the date command. So you can just add it into that same mutate. Since we use mutate at, you have to have another mutate here. So in this case, we have data date gets what? Once again, drop down, check to make sure that actually worked. And we have, there it is, DTTM. If we look over here, we can be reminded of what that is in our A data table. POSIX CT. So that did it. Any other requirements in here? No? Great. Lines 18 through 23, gotta skip a line because we didn't need it. Using one series of pipes per data file, aggregate across conditions such that participant number and mean scores of Q1 through Q5 across all 4 conditions are saved into 2 new tables, participant number, A aggregated table and B aggregated table. In other words, each aggregated table should have 1 row per participant, not 4. And extra credit if you can do that scalable. So understanding the difference between functions like aggregation versus transposition or aggregation versus restructuring was really important here. When we gather or spread, we are restructuring the data. We are literally taking columns out, turning them into variables. In this case, we're not restructuring, we're just aggregating. We're taking multiple cases and collapsing them down. That's different. That is a very different function. So let's try it. Line 18. So we're going to use one series per data file. So we're going to go ahead and start with a aggregate table. Gets, and we're going to start with what? We could actually just take a data table. If we want to aggregate, we want to collapse multiple rows into a smaller number of rows. What command does that? So we take group by, and what are we grouping by? Parnum. So if we run this now and glimpse it, what are we going to get? You should already know. What will this do? Will it change the data file at all? No. What it's going to do is it's just going to add back. Where'd it go? Oh, yeah. It's just going to add a grouping variable on Parnum. It's not actually going to change the structure at all of that existing table, or even of the new table. But we can use that information, that grouping information, to pipe it into something else. So what are we going to pipe it into? So if we summarize, and again, let's this is a scalable one, right? Yes. Let's not scale this first. How would you do this? Did you name them? You can name them too. Q1 mean equals mean Q1. Q2 mean equals mean Q2, etc. If we run this right now, you will see that it automatically subsets. So this is why you don't need to use select first, is because whenever you summarize, remember, you're actually not modifying the existing data set, you're creating a brand new one. So since you're creating a brand new one, it's only going to include the stuff you put in the summarize. So that's why you don't need select. It does the same thing. So here we have, I've summarized, and my grouping variable appears here, and my summary variables appear there. So I could just type out Q3M equals mean, Q4 equals mean, Q5 equals mean, and it will automatically drop Q6 through Q10. It will automatically drop the dates because the dates are unique. It will also drop anything that isn't unique unless I tell it to. So normally you would need to add group by there if you want to do that. But that's, again, a very messy, long way to do it. Did anybody here do a scalable version of this question? Yeah? 2? Oh, okay. What'd you do, Andrew?
I did summarize each. So summarize underscore each.
Oh, summarize each.
Then funds, FUS, open parenthesis, mean.
Wait, funds mean.
Open parenthesis.
Oh, funds equals mean. Open paren. No, funds mean.
Funds,
Mean.
Within the parenthesis mean, dot, comma, space, NA.RM equals true.
Okay.
Then outside of those two parentheses,
Yep.
comma, minus,
Like literally minus?
yeah,
Okay.
and then a vector to C with case num, stemper, and data date.
Case num stemper and data date. Yeah. Oh, you shouldn't need to do that. Wait, so you did case, oh, you didn't do it in
not
case
in
num.
quotes.
Yeah, you case num and what else?
Stimber.
Over and data date. Okay, and close that. Actually, I'm going to look at it. Wow. So you've used summarize each, which I actually have never used because of a warning we just saw, which has been around actually for a little while now. I'm going to point this out because nobody else should learn summarize each because of this guy right here. Remember we talked about deprecation before? So summarize each is no longer going to be a function in dplyr at some point in the future. So you don't need to learn it. And there's a bit easier way to do this. So yeah, wow, okay. So that did work. So you're using summarize each and you're passing, why is funds there though? Is that necessary? Oh, because it reconceptualizes as an anonymous function? Is that what you're doing? Yeah, I think it's because you have to reform this as an anonymous function. And I don't know that you need this. Unless that's something about summarize each. It must be. Huh. Yeah, so the new version of that makes it so you don't have to do that. So if we do a aggregate table, we can use summarize if. And in this case, you just had to figure out some characteristic, or summarize at using vars, the same way we did last time. I like summarize if here because the goal is to take all of the numeric variables. Like if we go back to a data table, or tibble, you will notice that the identifiers get lost anyway in the group by, so the only thing left are these numerics. So I can do summarize if is.numeric mean. And that does the same thing. A glimpse. Oh yeah, we got mean case numbers. Yeah, you're right.
That's why I never read it the way.
Yeah, we would have to do actually the same way. Summarize at vars Q1 through Q5. That should work then. Yep. So this would be the cleanest way to do it. And that notation, man, yeah. Compared to the implicit function in the summarize each, I see why I've never actually looked at summarize each, but now it makes a lot more sense why they replaced that with these other functions. So here, yeah, summarize at is I think going to give you the best sort of outcome here. But that does work, so that's good. If we look at the aggregate table, do we need to do the same thing?
Can you go back for the summarize at? So you did it. I didn't do it scalable. And I did it with the way that the Q1 equals mean Q1.
Yeah.
Can you do that in one, like Q1 and Q5? You have to write it down. Okay.
Yeah. So mutate specifically is done field at a time. That's actually why we have summarize at and summarize if, and mutate if and mutate at and all of them. It's specifically to provide that functionality because people wanted that with the original mutate. When they originally wrote dplyr, it didn't have anything to do like that. And they're constantly improving it to try to make it more succinct so that you can have cleaner code. So yeah, you specifically want the at or if you do it that way. When you do that, you really want to use these helper verbs if you can. I did a straight vars. You just saw we did starts with, but any of the helper verbs that are in the dplyr cheat sheet, if we go data wrangling cheat sheet, any of the helper verbs associated with select will work in there. Contains, ends with, everything, matches, num range, one of, starts with. Yeah. All of those work for all those commands. Okay. So if we do this one just the same way, it will work, I believe. Group by parnum. Pipe 2, summarize at vars Q1 through Q5 mean. Look at that. Glimpse to be aggregatable. Yep, same thing here. Okay. So those are those two pieces. And can't alt tab now. Next, we are at here, right? Yes, line 24. Using a join, add participant notes to each of your newly aggregated tibbles as a new column called notes. So, what kind of join is this? I hear a left join. Any other answers? Full join. Any other answers? No, he didn't inner join? It all work. All of them would do exactly the same thing in this context. Why, though? Same what? There is no missing data. Yeah. We have exactly the same number of rows in our data tables as we do in our aggregated tables. We have 100 right there, and we have, let's see if we can do this a little better. 200 right there. And if you look at notes, A notes is 100, and B notes, wherever it went, there we go. B notes is 200 also. So because of that, it means that a left join, outer join, and inner join are all going to do the same thing. In fact, a right join would too. So all of the joins are identical for this specific type of data. That would be different if those participant files, for example, only contained cases that had data in them. If the notes files only had notes, what kind of join would we need to use? So for example, if our notes file only has 4 rows and has 4 participant numbers where there were problems, what kind of join would we need to use? A left join. Because that way, it doesn't matter that there's cases missing. Wherever there are cases, it's going to pull them over. So in this case, though, we can do any of them. It doesn't really matter. I'm going to do tibble gets, we should do, I guess, an inner, we'll do left join. Left join, and we're going to join together tibble with a notes tibble. And what else do I need here? By. Now, I made this a little, I keep misspelling that. I made this a little bit easier for you. These are the same. In real data, that is really uncommon. If you need to merge files, it's very unlikely that your identifiers, unless you set it up that way, that identifiers in both variables will be the same. In that case, you can actually create a vector for by, a named vector that has the name of the variable in the left-hand side equals the name of the variable in the right-hand side. So if, for example, one was called par num1, I could do par num1 equals par num2, something like that. Alternatively, I could use a names or a call names command to change the name of that column in the other file. Doesn't matter. Both of those work. But you have to somehow tell it which things are the ones you want. In this case, we can just do par num. And conveniently, again, because I didn't want to make this ridiculously hard, we have the same sort of situation for B, so that works just fine too. We don't use any pipes here because there's only one assignment. If you were doing this on your own, you might have done this in a totally different order, though. You could have, for example, done all of the processing of the second file and then made one gigantic series of pipes for the first file, and as one of those steps, left joined in the file that you were already working with. Totally up to you. Again, it's a language. Lots of different ways to say things. So I would do it this way because I like the idea of parallel operations across different tables so that I can literally look back and see, oh, what was different in the way I processed these two, like straight there. Again, think of readability. Be very sympathetic to your future self. At some point, you will be reading this and trying to understand what you did. So think of your future self and try to write for them. What are you going to understand when you read this later? After a year, 2 years. We even have cases like what's his name? Brian Wansink. You familiar with that case? Food researcher, I think at Cornell, who is getting in a lot of trouble recently due to some shifty practices. He's being asked to produce data sets from 18, 19 years ago, and explain what analyses he was running on those data sets, and he's getting papers retracted when he can't produce data, that kind of thing. So very important that you have a full history of everything you did. You could get away with that. You could get away with not having this like 10 years ago. It was easy. No one would ever actually ask you about for data, at least in psychology. In other fields, that's not true. But in psych, it's just sort of this implicit trust that when you submit a paper that you did everything okay, and now the replication crisis is showing us that's not so true. There's a huge garden of forking paths where people just make arbitrary decisions along the way that make it more or less likely to find statistical significance. This is how you demonstrate what you did and why you did it. And you can still make those decisions. Like you can still say, after the fact, I decided that I was just going to drop everybody that looked weird, and here's how I defined it. But it will all be in this file, so somebody can see what you did. So it doesn't mean you can't clean data. It just means you have to be honest about it and put it actually in your data files. So very important. Lines. So those are our joins. And again, we could use inner, left, outer. Would not matter in this particular case. And did I actually do it? I did it, didn't I? Yeah, I got notes in Agger, and I got notes in Agger. Good. You might also, at this point, glimpse or view just to make sure that it did what you think it did. If I keep doing that. If I glimpse it, you can see that we ended up with the notes there. If I view it, I will get the same thing. And again, view is just the same as going over to a data frame and double-clicking on it. Same command. So you can see it looks like it came up perfectly. But if this was your data, what you might want to do at this point is literally just look at the first 10 or 15 cases, use head, and just make sure that it looks right on that version. Okay, so we go back here. Line 26. Using a single series of pipes, combine A Agger and B Agger, drop rows with research notes, and report the final ends split by data file source as a tibble displayed to the console. You might remember a few weeks ago I said I leave the hardest things for the end of the assignment so that if you screw it up, it does not affect other things you did. So this is the most complicated series of requests in this project. How do you do it? Bind rows. Bind rows. And what are we going to put here? That's an important piece. ID equals data set. Why do we have that? What does this do?
It creates the variable name for what I just named the A and B.
It formally takes this named vector. Again, remember a named vector is key value pair. So we essentially have a named vector here. We have an A with value A Agger table, B with a value B Agger table. So that means that A and B, those labels, will end up becoming a variable called, in this case, data set. We can see that happening just by looking at it. You can see all the A's right there. If we glimpse, what we end up with? Yeah, you see we have a data set variable with a character vector, values A. We could even, at this point, if I were doing this on my own, I would probably want to keep subsetting to check to make sure that happened. So that's why we have the rest of these operations, right? This represents the kind of checking you would do. So we pipe that into, what's next? Drop rows with research notes. How do we do that? Sure. You did group by data set here. To do what? So you need to group by at some point, but most likely you're about to use filter. Yeah, filter doesn't care about groups. Doesn't matter, yeah. So at some point you need to group by data set. Just because I wrote it this way, let's put the filter here though. So we're going to filter. How are we going to filter? Yeah. So the easiest way to do this is to literally look at this and figure out how it's coded. Missing values are coded as NAs. So that's real easy. We could alternatively look for is text present and check to see is length more than whatever, but that would work too. But the easiest option is just to look for NAs and then only keep the NAs. So we can do that using filter. And what does our filter command actually look like? Yeah. Is that NA notes? If we run that, you will see that we indeed dropped some cases because we had 300 before and now we're down to 290. So that works. I'm going to go ahead and add it to the full string here. Uh-oh, confused it a little. And now we have a group defined right here, groups by data set. Since we already talked about that. But yeah, you can put group by before or after filter. Filter doesn't care about groups. Remember that grouping is really majorly for what? Summarize. So we're going to pipe in our next summarize. And our report final ends split by data file source as a tibble. So we've already got the as a tibble taken care of because we're displaying to the console. And we're operating entirely within pipes, so it's already automatically a tibble. We need to report final ends, though. How do we do that? Done. If we wanted that to look nice, we could also give that thing a name. So we could say, like, group in equals, for example. And that gives us back data set source, A and B, group in. I might even call this source personally. I have to change it down here, though. Here we go. And so now we have data source, AB, group in, numbers. We'll check that against the assignment just to make sure that's compliant. Using single series of pipes, check. Combine cases from A and B, check. Drop rows with research notes, check. Split by, and report final ends split by data file source. So we split it, check, and then we reported final ends in that split format. Check. Done. Okay? Key to understanding what happened, again, is recognizing that these commands always operate on the results of the previous one. And 2, summarize creates a brand new data set using the return in the previous line. So as of right here, we still have a 300 case data set at this group by command. But as soon as we get to summarize, it says, aha, create a brand new data set based on that. And in this case, all we're doing is calculating in, and since the groups are defined, it calculates them by group. And if we didn't have groups, what would happen? If I skip the group by, what would I get back in that final table? Yeah. So if and we'll actually even just do it right there, 290. All group by does is that, and actually let me add this back in and then cut it off right here so you can see. All it's done is literally added this notation right here, groups source 2. So I group by source and it tells me, aha, there's 2 of those, and it's called source. By itself, that's all it does. Literally nothing else. If you run mutate after this, it's ignored. If you run filtering after this, it's ignored. If you do select after this, it's ignored. But if you run summary functions, it will split by whatever your groups are. So in this case, when I ask for in, it says, aha, there's a grouping variable. So I'm going to do this summarize command split by those 2 groups. We could use it any other way. So for example, if I did, let me have to type back in though. All right, so you have to tell it what you're going to do a mean on. So in this case, what's happening is I have 2 groups, filtering still, grouping by source, and then because I'm asking for mean Q1, but that group exists, that means I'm reporting the mean split by group still. If I cut out that source command and rerun it, then I end up with just getting the mean for everybody. But it's only summarize that does that. Summarize is the only verb that we talked about that actually cares about grouping variables. So that's literally it. Running group by itself does literally nothing, like in terms of your output. All it does is it implicitly assigns groups inside the data set. It's essentially an attribute of the tibble. You're telling the tibble, hey tibble, there's groups in here. But that's it. That's all it does. So you have to combine group by with other commands in order to actually see something happen. Does that make sense?
Yeah, so mostly just with summarize.
Yeah. Or summarize that, or summarize all of the summarize family. Yeah. Specifically because of this shape right here, this summary piece. This is where the groups are used. So instead of creating 1 row, we're creating multiple where they have groups. Okay. And that's we're at the end, right? Yeah, that's the last requirement. So that's how you should have done it. How did you do? And usually we got it pretty good. Like the average in the projects is like a low 90s somewhere. So we're doing pretty well on average across these things. But this is the first time where there's more ambiguity. So I'm wondering if that hurt people. Is it harder? Yeah, a little bit harder. Now that you see this version, though, does it make sense? Yeah. So this is, I mean, again, it's a lot of it's about thinking in these terms. Once you start to have kind of a fluency with it, and you're not sitting there and thinking they're like, well, I can use this function this way or this function this way. You just are like, oh, there's a whole set of things I can look at to figure that out. I hope you also paid attention to how I look up documentation, because I still do this. It's not like I have all this memorized. I'm literally in real time when I'm coding saying like, wait a minute, I don't remember how to use that thing. And I go look it up. Or I go look at the cheat sheet. Or I go find a resource that will help me. Don't just write stuff. Develop. Don't write. Okay. That's it.